Okay, I'm going to have a look at chapter 13, which is surds. There's basically two topics in this: simplifying surds and rationalising the denominator. Simplifying surds, basically, you try to break down using squared numbers. So if I look at the number 50, that can be broken into a 2 and a 25. The square root of 25 is 5. The square root of 2 can't be broken down, so you're finished. Now, the way you want to do it is you want to put the whole number first and the surd at the end. Now, if you look at this one here, it's 3 root 45. So the 3 just sits there. You do nothing with that at this stage. Root 45 is a 9 and a 5. Square root of 9 is 3, so that becomes 3 times that there, 3 times root 5, to give you 9 root 5 altogether. The next one, you get this wee 3 sitting outside, so just let it sit there. You're looking for a square number that goes into 44, so it's a 4 and an 11. 3 is just sitting there. Root 4 becomes 2, so you write times 2. Root 11 can't be broken down. You tidy it up, 3 2s are 6. Root 28, the square number that goes into that is a 4 and a 7. And it's divided by root 7. From your fractions, root 7 and root 7 cancel, leaving you with root 4, which is 2. This one here, root 6, does not break down into a squared number. So in this case, what I'm going to do is I'm going to write it as a 2 and a 3. And the reason I wrote it as a 2 and a 3 is because of the 3 in the bottom line. And I knew that would cancel off. Give me root 2 times root 2. Root 2 times root 2 is root 4, which is an ordinary 2. So if you ever have something like root 3 times root 3, the answer is 3. Root 4 times root 4, the answer is 4. And so on. Looking at this one, it's 3, ordinary 3 sitting there. 18 is a 9 and a 2. See the way I keep the square root signs in at this stage? Root 6 doesn't break down into squared numbers. I'm going to write it as a 3 and a 2. The reason being, because that root 2 and that root 2 will give me an ordinary 2. So we'll go through that slowly. So it's 3 times root 9 is 3. Root 2 times root 2 is root 4, which is an ordinary 2. And then you're left with that root 3. So 3 times 3 is 9 times 2 is 18, root 3. Now, this one here, you've got an ordinary 3. 50 breaks into a 25 and a 2. Take away 2. Root 8 breaks into a 4 and a 2. Now I'm going to take that a wee bit quicker now. So that's 3 times 5 is 15 root 2. So it's 15 root 2 minus 2 times, that becomes 2. So 2 2s are 4 root 2. So you've got 15 root 2s, take away 4 root 2s, leaving you with 11 root 2s. Similarly, this one here, so it becomes 3 times 2, which is 6 root 3, minus 2 root 3, which gives you 4 root 3. 6 take away 2 gives you your 4. This one here, 2 root 3, doesn't break down. The squared number goes into 12 is a 4 and a 3. So that is fine, that first term. 4 root 4 can be written as a 2 root 3. So 2 root 3 and 2 root 3 gives you 4 root 3. Now, multiplying. This is just you're multiplying at your brackets. So take your first term and multiply through. 2 times 3 is 6. 2 times minus root 7 is minus 2 root 7. Then take the second term and multiply through. Positive root 7 times 3 is positive 3 root 7. And the last two. Positive root 7 times negative. A positive and a negative gives you a negative. Root 7 times root 7 gives you an ordinary 7. And you notice when I multiply out those brackets, I'm going 2 times 3 is 6. Then it's these two terms. And I go sine, number, surd. It's like when I do sine, number, letter, only it goes sine, number, surd. If you look at these two terms, sine was positive number 3, surd root 7. And the last two terms, the sine they're different, so it's minus. There's no number, but the surds break down to give you a 7. So tidying this up, 6 take away 7 is minus 1. Minus 2 root 7 add 3 root 7 is 1 root 7. Now the next wee one is a squared bracket. To square a bracket, you just multiply it by itself and just go through the same way. 2 times 2 is 4. 2 times 3 root 5, so the sign is positive, the number 2 times 3 and the root. Now doing these two terms, so the sign is positive, the number 6 and the root 5, so it's positive 6 root 5, and the last two terms, the sign is positive. Now just be careful here, the number is 9 and the root becomes root 25, which is 5. So tidying that up, 4 add 45 is 49, add 12 root 5. And this next one here is a similar one. It's got a negative sign, so I have to just be careful here. So it's root 6 minus 1 times root 6 minus 1. So take your first term through. Root 6 times root 6 is ordinary 6. Root 6 times minus 1. So I'm looking at these two terms. The sign is minus, the number is 1, and it's root 6. So just minus root 6. Now taking these two terms, the sign is minus, number is 1, and the root is 6. So minus 1 root 6. And the last two terms, two minuses give you a positive. The number is 1 times 1, which is 1. And there's no roots there. Tidying this up, 6 add 1 is 7. Minus root 6, take away another root 6 is minus 2 root 6. And the last one I have here of this type, root 12 breaks into a 4 and a 3. Times it by root 3. Root 4 is 2. Root 3 times root 3 is an ordinary 3 to give you an answer of a 6. Now the next wee section here in Surds is rationalising the denominator. Basically, you multiply top and bottom by the bottom surd. I've got a wee tip here. If you have more than one term on the top, put brackets around it. Now if you look at my few examples here, the first one is 8 over root 2. So what you're going to do is you're going to multiply top and bottom by root 2. So it's 8 times root 2 for the top. Root 2 times root 2 gives you an ordinary 2. Then tidy it up. 8 divided by 2 is 4 root 2. This one here, I have got more than one term in the top, so I'm going to put brackets around it. So it's 2 add root 3 over root 3. So I multiply top by root 3 and the bottom by root 3. Just multiplying out your brackets. 2 times root 3 plus root 3 times root 3 is an ordinary 3. And the bottom becomes a 3. So it's 2 root 3 plus 3 over 3. Now if you're going to cancel that down, you must divide each term by 3. So that becomes 2/3 root 3 plus 3 divided by 3 is 1. The next one here, that first number is fine, so don't touch it. The next number here is where you're going to do your work. So we'll do it in a different colour. So it's 5 root 2 times root 2 over root 2. So the first number is not changing. The second number becomes 5 times root 2, which is 5 root 2, and the bottom line becomes 2. Now that tidies up, because what you have there is you've got 10 root 2's plus 2.5 root 2's. So altogether you've got 12.5 root 2's. The next one is the same idea. The first number, well, that one breaks down into a 9 and a 3. The second number is where you have to rationalise. So it's 2 over root 3 times root 3 over root 3. Sorting out the first term, the black one there, that's 3, an ordinary 3 root 3 minus, and sorting this out is 2 root 3 over a 3. So what you have there is you've got 3 roots, take away 2/3 root. So 3 take away 2/3 is 2 1/3 root 3. And this one down here is very similar to the one above it. The first number breaks down into a 4 and a 5. The second bit needs the surd fixed on the bottom line. So you multiply it by root 5. The first number becomes 2 and then a root 5. The second one tidies up into 2 root 5 over 5. So what you have here is you've got 2, take away 2/5, giving you 1 3/5 root 5. Now I would like to do one more wee example in there. It's one of the ones where there's 2 terms on the top. So say for instance if you had root 3 minus 4 root 2 over root 6. Now nothing breaks down in that one. There's no point in writing that as a root 2, root 3, so just leave it the way it is. When you have more than one term on the top, the wee tip is to put brackets around it. So it's root 6 times root 6, it just helps when you're multiplying out. That becomes root 3 times root 6, which is root 18. These here too become minus 4 root 2 times 6 is 12 over 6. Now that one breaks down into a 9 and a 2, so root 9 root 2 minus 4. 12 breaks into a 4 and a 3 over 6, and that tidies up. Root 9 is 3 root 2 minus 4 times root 4 is 2, so 4 times 2 is 8 root 3 all over 6. So basically for surds, you've got the simplifying surds, where you try to break them down using squared numbers. There's quite a lot of different questions I can ask you there. And rationalising denominator is the other type, where you multiply top and bottom by the bottom line. If you ever have come across a surd on the bottom line, you will always rationalise the denominator. You do not want to leave a surd in the bottom line in maths.